SSL enables devices to transmit data over the internet in a way that prevents unauthorized parties from reading or modifying it. It's a fundamental security mechanism used in banking, web applications, and IoT systems. In this video, I will show how SSL works in practice using an example of XIAO-ESP32C6 sending data to a server. I will explain how to generate your own certificate and what network traffic looks like before and after enabling SSL. In hobby IoT systems, devices often transmit data in plain text. This means that anyone on the same network can intercept information such as sensor readings, device identifiers, or server endpoints. Of course, we don't want anyone to have the ability to capture our data. Let's build a practical example. A simple test architecture consisting of three elements: an IoT device, a data aggregating server, and an eavesdropper. The XIAO will act as the IoT device sending sensor data. A server written in Node.js will receive this data on the backend. Using Wireshark, we will capture and analyze the communication between them. We have a simple server with two endpoints. Sending a request to the first one prints hello to the console and returns a status OK response. The second endpoint allows us to send data, which is then displayed in the console. First, we will start communication without any encryption. The XIAO will send data to the server using standard HTTP. Next, we will capture the traffic in Wireshark and see that the transmitted data is fully readable. Sensor values and request details can be viewed without any difficulty. If you are wondering how professionals create electronics without chaos and with maximum collaboration, the answer is Altium Develop. Imagine an environment where you eliminate the problem of manually emailing files to others, such as mechanical engineer for PCB verification, and start working in real time in one cloud. Altium Develop is an advanced professional central hub that integrates the PCB design tool with the broader ecosystem. With it, you can forget about the frustration and delays that come from constantly losing context and having to manually track corrections. A certificate allows the client device to verify the server's identity and establish a secure, encrypted communication channel. This ensures that the XIAO is connecting to the correct server rather than an impersonating device. Additionally, even if someone intercepts the data, decrypting it is impossible without the session key, which is known only to the client and the server. But what exactly is the key and how is it established? First, the device initiates the connection with a client hello message and sends its public key. The server responds with a server hello message containing its public key and a certificate that confirms its identity. Both sides independently compute a shared secret from which a session key is derived and used to encrypt and decrypt messages. Next, we will generate our own SSL certificate using OpenSSL by creating a self-signed certificate valid for 365 days along with a private key. After that, we configure the Node.js server to listen over HTTPS with TLS enabled and to use the generated certificate and private key. Finally, we configure the XIAO to work with TLS and take another look at Wireshark. As you can see, it's no longer possible to inspect the contents of the packets.